Three, two, one, start. Digital Solutions FA1 Investigation. Technical Proposal. Task Overview. Mind Map. This mind map shows an effective overview of the innovative digital solution. It shows what tasks must be completed, who and what the technical proposal is for, and how it will be presented. Provides details of the innovative digital solution and the technical proposal is for, and the relevant datasets that will be analyzed. Evaluation criteria. Prescribed criteria. Personal, social, and economic impacts and considerations to identify risks. User interface prototype. Accuracy and efficiency of the algorithms. Low fidelity, non-coded prototype digital solution. Self-determined criteria. Able to be played by users with certain disabilities to be able to reach a wider audience. Have good replayability so that the younger audience plays the game more. Encourage students to learn times tables by playing the game. Implement a scoring and time limit system to add a level of competitiveness for students to compare with friends. Menus must flow smoothly between each other to create a unified experience. User interfaces must utilize CARP principles to make it look nicer and more learnable. Constraints. Copyright laws. Audio, video, images. Time frame. 5 weeks. Motivation. Many other assessments to work on. Knowledge of creating UIs. User disability. Find solution to certain disabilities. Programmer and user hardware. Younger audience usually has slower hardware. Must account for touchscreen or not touchscreen. Introduction. This technical proposal is to be created for Fox Valley State School so that they can use it as a part of their curriculum for teaching literacy and numeracy. The innovative digital solution is a computer game that is designed to assist students at the school to learn. The technical proposal is to be presented to the teachers at Fox Valley State School and to be targeted towards the students by making it colorful and fun. The innovative digital solution is being proposed for development so that it can be used as an effective learning tool for the teachers at Fox Valley State School to use with our students. It will help with the students' numeracy by assisting them to memorize their times tables in a fun and safe environment. The innovative digital solution will be developed through the use of the Python coding language. This will also use the PyCharm IDE to code the digital solution, as PyCharm makes importing packages easy to do. The user story. The proposed innovative digital solution is to be developed for the younger students at Fox Valley State School, such as Dale Smith, who is 10 years old, is interested in rugby league, computer games, and building. His hardest subjects are being English and maths, his easiest being HP. His personality being loud and outgoing, has a BYO device, and wants to pursue a career in the building industry. And Sally Bruce, who is 12 years old, is interested in art and fashion, finds maths a harder subject, finds art and science easy, is quiet and reserved, has a BYO device, and is considering medicine as a future pathway. Another group of people that this innovative digital solution will be developed for is teachers. An example of one being Finken Lorbs, who is 42, is interested in teaching, struggles to teach maths, finds teaching technology easiest, is not the smartest, does not have a BYO device, and is already a teacher. The innovative digital solution will appeal to the target audience through the use of bright contrasting colors, sound effects, and replayability to list some. It will also be useful for the target audience as the students struggle with maths, and the game will make learning more engaging and enjoyable. It will also be useful to Finken Lorbs in teaching maths, as he will be able to set aside a part of the class where they can learn using the digital solution, while he can plan future maths lessons, making the load lighter for him. The innovative digital solution will appeal to be useful for the target audience so that the high school students can win the competition and make learning numeracy enjoyable. There are many relevant data points or statistics that are applicable here, including the Australian Communications and Media Authority, stating that 47% of children aged 6 to 13, male and female, either own a mobile phone or have access to one, and that playing games was the most common activity that children use their phones for. This means that gamifying learning would be an effective solution for the targeted audience. The data story. Existing solutions. A relevant existing solution for a game is Flappy Bird. Flappy Bird is a side-scrolling game that has a bird in the center of the screen that is affected by gravity, where the player must avoid obstacles going past them by tapping the screen to make the bird flap and make it gain height. The innovative digital solution will take inspiration from the user interface, gameplay, and principles/elements of visual communication from Flappy Bird. This would include the score counter in the center top of the screen, a menu screen with the score and high score together in a box that contrasts the background to stand out, and the restart button that is aligned to the center of the screen and contrasts the background to catch the attention of the user. This also includes the main gameplay loop of Flappy Bird, where the user has to avoid obstacles approaching them by using gravity and well-timed jumps. The modification of the main gameplay loop that this innovative digital solution will have is to make the user quickly answer random times tables questions whenever they die, to save themselves, or when they pass through a pipe to gain the user a point. The chosen existing solution will influence the proposed innovative digital solution in terms of usability principles through the contrast of the important information orange-yellowy colors and the background blue-greeny colors, so that the important information is easily accessible and stands out. Alignment and proximity of the main menu buttons and information that is centered out and close together, so that all of the important information is in one spot, making it easier for the user to use the solution. And repetition through the different scenes, having the same background so that the game feels more fluent and simple. The chosen existing solution will influence the proposed innovative digital solution in terms of functionality through having the same gameplay loop, with added times tables questions so that the digital solution can be effective at assisting the target audience in learning numeracy. The proposed solution: user experiences and user interfaces. The proposed innovative digital solution will provide positive user experiences by adhering to usability principles, such as allowing users to input numbers into the answer box if they do not have access to a keyboard for accessibility, making the game entertaining and replayable to increase the effectiveness, having back buttons in the game and a quit button in the main menu to allow the user to exit at any time for safety, having many times tables questions to improve the utility and functionality as a learning tool, and having simple, easy to learn user interface for the learnability of the innovative digital solution. Algorithms. The algorithm for the biggest bird game scene. Inputs: number input, num input, touchscreen, touch spacebar. Processes: start, declare all variables being the score, high score, the player alive status, the death question status, the pass question status, variable x, variable y, the answer, the num input, and the loss status. If the player presses the back button, go to the main menu. This is the main game loop. So while the player is alive, check collision with obstacles, check if player passed through obstacles, check if the screen is touched, apply gravity on character, move background and obstacles backwards. Loop when answering a question to save the life. Generate randomized times tables question. If the user answers correctly, reset bird. If user answers incorrectly, lose. Answer question to gain score loop. Generate randomized times table question. If user answers correctly at a score point and reset bird's position. If user answers incorrectly, reset bird. End of game loop. Set high score if previous score is larger than previous high score. And change screen to main menu. Outputs: score, high score, set scene to main menu scene. Algorithm for biggest bird startup screen. Touch screen. Touch spacebar. Process: start game when user touches screen or presses space. Outputs: set scene to game scene. Algorithm for biggest bird main menu. Inputs: pressing quit button, pressing restart button. Processes. Show previous score and high score. If player presses quit button, quit game. If the player presses the restart button, restart the game. Outputs. Score, high score, quit game, change scene to game scene. Evaluation and recommendations. Criterion. Personal, social, and economic impacts and considerations to identify risks. Evaluation. User does not require an account to be able to play. User's personal information is not stored or required. Digital solution will be useful for targeted audience. Uses a high score system so that the solution can spread socially. Number input on screen in case if user does not have access to a keyboard. Recommendations. Incorporate a feedback option to allow users to provide feedback to enhance the solution. Add the ability for the user to choose a range of questions for the difficulty level of the questions. Add a way to share high score online so that the game can get more social users. Criterion. User interface prototype. Evaluation. Success. The provided user interface sketches detailed elements and principles of visual communication, potentially improving end-user experiences. Recommendations. Add a little detail in the backgrounds to make the game more eye-catching. Criterion. Accuracy and efficiency of the algorithms. Evaluation. Algorithms are accurate and efficient at providing a gamified experience for learning times tables questions. Recommendations. Adding a timer so that the solution can improve the speed at which users can do times tables questions. Criterion. Low fidelity non-coded prototype digital solution. Evaluation. The low fidelity non-coded prototype digital solution was completed through the use of Figma.com. It was successfully completed and caught the attention of users with its bright colors and high contrast. Recommendations. Use a more complex and in-depth image editing system to create a better prototype. Self-determined criteria. Criterion. Able to be played by users with certain disabilities to be able to reach a wider audience. Evaluation. The final digital solution will make use of sound to assist users who have difficulties reading. Recommendations. None. Criterion. Have good replayability so that the younger audience plays the game more. Evaluation. The digital solution does have replayability through having randomly generated questions and a high score system. Recommendation. Incorporate a way to share scores with others to introduce a level of competitiveness. Criterion. Encourage students to learn times tables by playing the game. Evaluation. Through making the game look enjoyable, students will be encouraged to learn times tables to get better at the game. Recommendations. None. Criterion. Implement a scoring system and a time limit system to add a level of competitiveness for students to compare with friends. Evaluation. A scoring system and high score system were implemented into the solution to add a level of competitiveness for students to compare their achievements with friends. Recommendations. Add a time limit system to use time pressure to improve and make the game more difficult. Criterion. Menus must flow smoothly between each other to create a unified experience. Analysis. Evaluation. The different scenes throughout the game flow smoothly between each other to create a unified experience through making the backgrounds the same. Recommendations. Adding a transition between scenes to ease the user into a new scene. Criterion. User interface must utilize cart principles to make it look nicer and make it more learnable. Evaluation. The innovative digital solutions user interface utilizes all of the cart principles to create a nice and learnable user interface. Recommendations. None. Constraints. Criterion. Copyright laws. Audio, video, and images. Evaluation. The solution uses images taken from a website in the prototype. These images are properly referenced to avoid copyright laws. Recommendations. For the final solution, create all images myself. Criterion. Time frame. 5 weeks. Evaluation. 5 weeks to create the innovative digital solution was difficult but worked out in the end. Recommendations. To use better time management skills to spread out the work evenly. Criterion. Motivation. Many other assessments to work on. Evaluation. Other assessments did get in the way of this, making it more difficult to adhere to the time limit. Recommendations. None. Criterion. Knowledge of creating user interfaces. Evaluation. While I am fairly unknowledgeable to creating user interfaces, I effectively use the elements such as cart, learning class to help. Recommendations. Research online how to better make UIs and more elements. Criterion. Use the disability. Find solutions to certain disabilities. Evaluation. There is currently no assist to user disabilities. Recommendations. Use sounds throughout the final solution to assist users that cannot read or have difficulty seeing. Criterion. Programmer and user hardware. Younger audience usually has slower hardware, must be accounted for, touchscreen or not. Evaluation. The innovative digital solution accounts for users having slower hardware through its simple concept and graphics. It also has options to play either using a touchscreen or if the user has a touchscreen device, or using the spacebar if the user is playing on a computer. Recommendations none. References.